Hello everyone, so today we're going to go over section 7.1, exploring the characteristics of exponential functions. So we'll be looking at two different types of exponential functions. The first one is of the form y equals a times b to the x, where a is a coefficient, b is of course the base, and x is our variable. Okay, so those are the three components of the function. Okay, just a basic exponential function for now. A is a real number that's not 0, and b is going to be greater than 1. So the second type of exponential function we'll be looking at, the formatting is the same except for the base. It's going to be a little bit different. Okay. So if we go ahead and compile this table of values with f of x equals 10 to the x, so in this case, the coefficient is just going to be 1 here. And of course, the base is 10. So we can substitute in the different values of x, starting with -3. So 10 to the -3 power, that will give us 0.001. 10 to the -2 power will be 0.01. 10 to the -1 power would just be 0.1. 10 to the 0 power is just 1. And then we have 10, 100, and 1000 respectively. So you can see as we move left to right and we increase the value of x by 1, we multiply the value by 10. Okay, so if we were to go ahead and draw this graph, it's going to go ahead and label this graph to the right here with the quadrants 1, 2, 3, 4. Just a quick reminder of that. Okay, 3 and 4. Okay, so because the axes are not labeled with a scale, so you just use whatever we need here. So in this case, the y-intercept is going to be 1 because of the 0.01 right here. And as we move left to right, you can see the numbers on the left of the y-axis are very small, and then it increases to become 1. And then once we're past that, increases very rapidly, going from 1 to 10 to 100 and then to 1,000. So what you need to label as the y-axis. And this will be the general shape of the exponential function that's increasing. Okay, some quick properties. You'll notice that these values are not going to be negative or 0. So this graph will not cross the x-axis, so it will have no x-intercept, so this will be none. The y-intercept is just going to be 1 in this case, but it is in general going to be the a value. The domain x is an element of the real numbers. The range y is greater than 0. Again, no x-intercepts there. And then finally, the end behavior is going to be 2 to 1. Okay. So next we have a very similar example. What if a is not 1? So we have g of x is equal to 2 times 5 to the x power. Again, we'll make a table of values first. So 5 to the -3 power times 2, we actually get 0.016. Since the base is 5, as you move from left to right, you're going to multiply by 5 each time. So 0.016 times 5 is 0.08. Multiply that by 5, you get 0.4. Multiply that by 5, you get 2. 2 times 5 is 10. And then 10 times 5 is 50. And then finally 250. Okay, and then go ahead and draw the graph again. This time we're not going to label the quadrants, but we do want to label the y-intercept. So in this case, it is 2. The graph will be very similarly shaped. Again, we don't have to scale, so as long as you can show that it's increasing and has the exponential function shape that is sufficient for a sketch. Something like that. It's good. Again, the properties, just like the last one, no x-intercepts. The y-intercept is the a value, which in this case is 2. The domain, same as before. The range, same as before. And finally, the end behavior. So we're going to have 2 to 1. We're going to add a little bit extra. It is increasing, so just going to make a note of that here. Now, if a was negative, then this graph will be flip upside down, of course. So the quadrants will be different. That is to say, the end behavior is going to be different. The range is going to be different. But this is just introduction, so we'll save that for a later date. All right. So next up, we have exponential function. Again, the same format, but in this time it's a little bit different. We will have the base that are between 0 and 1. So it's not just less than 1. It has a little bit more specific than that. It's going to be from 0 to 1. So let's make that correction there. There we go. All right. Let's check this part out. The first one, just very basic version of this. The a value is just going to be 1 here. B value is 1/2, which of course is between 0 and 1. And again, we go through the table of values. So in this case, 2 to the negative 3 power is 8. And as we move left to right, we will multiply by 1/2, which is the base. So 8 times 1/2 is 4. Multiplied by 1/2 is 2. Multiplied by 1/2 is 1. And then we have 1/2, a quarter, and finally 1/8. So the graph will be very similar to what we had before, but it will be flipped horizontally. And that is to say, it will be decreasing exponentially. So both the front page and the back page contain the exponential function. It's just the ones on the front page are exponentially increasing, whereas these ones are exponentially decreasing. So look like that. Label our y-axis. Some of the properties are very similar to the questions from the first page. So again, no x-intercept. The y-intercept is just the a value, so it's still 1. The domain, x is an element of the real numbers. Range y is greater than 0. The end behavior, again, quadrant 2 to quadrant 1, but it is decreasing, so make sure you make a note of that. All right. One more. Again, very similar kind of thing. This time around, the a value is 8, and the b value is a quarter. So 1/4 to the negative 3 power, and then multiply by 8, you actually end up with 512. And then you simply multiply by a quarter or divide by 4 as you move from left to right, so you get 128, then 32, then 8, which matches the y-intercept, so that's good. And then we have divided by 4 is 2, divided by 4 is 1/2, and then 1/8. So again, very similar to the previous example now. Exponentially decreasing graph with y-intercept of 8. So something that looks like this. Okay. Again, no x-intercept. Y-intercept is going to be the a value, which in this case is 8. Since a value is positive, actually, the domain is going to be just an element of all real numbers. Sorry, x is an element of the real numbers. This is where the a value is more relevant. So since a is positive, the range is just y is greater than 0. and the end behavior, once again, 2 to 1, and once again, decreasing. All right. So that's a brief introduction onto the very simple form of the exponential function. We talk about how we can have a exponentially increasing function and also how to make an exponentially decreasing function. So that's it for today. Thank you for listening.